Well, here we see the soil moisture probe that I've been using up to this point, which is the Adafruit probe here, and here is the Catnip Electronics probe from Vilnius, Lithuania. And I've just finished attaching it to the male plug here that I use to connect cables to my Swarm Eval Kit satellite transceiver. Yeah, they were originally designed, these black cables, to connect LED lights, poolside LED lights together into their power source. So I think they're pretty well designed for being in the rain. Also, I've upgraded the heat shrink tubing that I'm using to cover up my solder connections to an adhesive lined one, which you can see a little bit of the adhesive during the heating process to shrink the tubing. A little bit of it comes out. That indicates that you've got a good seal there. There's a little bit here also, and you can see that on the probe that was sent to me from Catnip Electronics, that there's a similar bit of glue coming out here where the heat shrink tubing was used to cover up the electronics of the probe. So should be good, should be weatherproof. I had to do a little bit of continuity checking to figure out what color wire to hook to what color wire from the probe to the cable here. I thought that I had written all that down, but I couldn't find it, so spent a little bit of time with a continuity checker to get that figured out first. So hopefully the probe is okay. Now we'll hook it up to the eval kit, and we'll upload the new software to the eval kit and see what happens. Well, here we have the new moisture probe stuck into soil in a planter, and there you can see my connection to the cable that goes here to the satellite transceiver. Eventually will come into view. So the solar panel on this was quite effective. This device I had sitting idle in the living room, just facing the picture window, and that kept this thing charged for several weeks. When I first brought it out here, it started right up, full throttle, and sent off a couple of messages that I had stored in it weeks and weeks ago that had never made it up to the satellite. Got those sent off, but now we're just testing it to see if it will work successfully in getting moisture and temperature measurements from the new probe and sending them off. So we'll just have to wait and find out what happens. Well, what happened was a whole bunch of nothing. So I brought the satellite transceiver back in and opened it up and connected to the microcontroller there and examined the code more carefully, and found out that I'd made several mistakes that prevented anything good from happening. The first thing is right here where I initialize the I2C bus. I call it I2C_bus here, but everywhere else further down in the code I just call it I2C. So of course that wasn't going to work. Now also here I'm referencing the particular type of connector, the stemma connector, that is a miniature microcontroller connector that I was using on the microcontroller similar to the one in the eval kit satellite transceiver, but not identical to it. And the one in the transceiver is not the miniature stemma version, so I had to also change that just to board.I²C. And then further down in the code where we define the function that's going to read the sensor, or in this case sensors actually. There you can see that I'm saying I²C, not I²C _bus. So just changed everything to I²C, got rid of the underscore, and then here also I'm missing a parenthesis. Here I'm taking the 2-byte value that I read for temperature and multiplying the most significant byte by 256 and adding it to the least significant byte and then dividing by 10, because that's just the way things are set up here. It's reading Celsius degrees, but it's reading 10 times the Celsius degree, so that you can then all those calculations can be done with integers and then divide by 10 to get a decimal result. And I in grouping the numerator here of the fraction, I have a terminating parenthesis, but I don't have a starting parenthesis, and so of course it wouldn't work for that reason either. So it was over-determined not to work. And with those corrections, though, we were able to get this very first result here in the Hive, which is the server for the Swarm satellites, where they download all of the satellite data there, and you can go take a look at your values. And so we've got our first report here from the satellite, which was received at the Swarm location, their server, at 10:37 a.m. Today, and it was actually a measurement that was taken at 13:01. That's Universal Time Coordinated, UTC. So it was actually 9:01 a.m. here, and I got a 22.9 degrees Celsius temperature reading and a moisture level of 315, which is a little bit moister than dry air, which gives us a reading we saw of a little bit over 250, I think. So then we'll have to make artificial rain out there and watch what happens to the readings as we go. But the important thing here is that it's actually working. It's actually created a message with appropriate values and uploaded it to the satellite. The satellite downloaded it to the Hive server, and we're able to retrieve it. So we'll make it rain artificially out there, and then we'll watch those values and see how they change, and go through a couple cycles of that and report on that next. But yay, it works, or it lives.